We don't hear you,
Okay. Can everybody hear me and see?
Yeah, perfect.
Yeah? Okay. So, hello everyone, my name is Maddie Kelleher. I am from Dublin in Ireland. I have lived in Barcelona for since April of last year. My professional experience is about 1.5 years spent as a technical recruiter where I found a passion for technology. Then my academic experience before that was a master's in biopharmaceutical engineering and a BSc in equine science. As you can see, I'm an avid horse rider, proud feminist, and most importantly, I am an aspiring data scientist. So a brief introduction to the project that I'm about to show you now is going to be a data visualization project. So I'm going to try and take you on a bit of a journey, maybe invoke a few emotions, we'll see. But just before that, an introduction is the data that I've used for this project was downloaded from the World Health Organization and UN AIDS repositories. There's some information there from the CDC as well and from different places that I've referenced throughout the project. Additionally, the plots and graphs that you're about to see were written with Python in the Jupyter Notebook, and I mainly used Plotly and Seaborn libraries for those generations. And yet to come in another part of the project, which unfortunately just wasn't quite ready, is that I'm currently building a single-page Dash application that will be, in an ideal world, deployed on Heroku. So do please feel free to go to my GitHub and play around with some of the graphs, which are interactive, and have a look at that webpage that I will put the link for up on my GitHub as well. Pandemonium, a comparison of global pandemics in the 20th and 21st century. So the picture that you can see here was the words were scraped from a web article and the text was processed using natural language processing in the NLTK library and then projected over a map of the world. The words were weighted and their size is indicative of how many times they appeared in that article. So I would imagine while I've been explaining to you how this is made, you've picked up on some of those words, among which are extinction, global warming, asteroid, and pandemic. That article was one on Global Catastrophic Risk Index. So what are the probability of these events that are likely to end human civilization as we know it? And the probability of a world-ending global pandemic was 0.05%. How lucky we are. A footnote in the bottom right-hand corner for anybody who is particularly skeptical was the probability of a world-ending engineered pandemic was 2%, which is significantly higher, but I'll let you have your own opinions on the nature of the coronavirus. So how close have we gotten to a world-ending pandemic? This is a timeline of some of the pandemics that we've seen since the year 2000. SARS, I'm sure you'll remember it. H1N1 is the swine flu. Some of you actually might be vaccinated against it. MERS, who is the ugly stepsister to coronavirus, along with SARS, and the Ebola virus that was quite a severe pandemic around the continent of Africa that lasted for about 2.5 to 3 years. Additionally, there was many other ones, but notably there was Zika virus as well and Nipah too that were quite significant pandemics. And just to get an idea of the numbers and what it all meant, because I don't know about you, for coronavirus, I'm following the statistics pretty closely, but I didn't follow any of the other ones. Again, like I said, MERS and SARS that are in the same family as the coronavirus, confirmed 2,221, death rate 886. My God, Spain was reporting that kind of as a daily death rate. These were global pandemics that made the news, even though we never saw them here. The worst was Ebola, and really, when you look at those numbers, it's quite small compared to the coronavirus. COVID-19, our good friend. So this data that I downloaded from the World Health Organization, I downloaded on the 23rd of June, so about just over 3 weeks ago. Now, as we are probably all aware, the virus has re-entered a state of exponential or logarithmic growth. So at the moment, probably these levels of the cases and also the death rate subsequently are significantly higher 3 weeks on. But on the 23rd of June, there was almost 10 million confirmed cases, almost 500,000 deaths. The case fatality rate, which is a function of the amount of people who will get the virus at all, who will die from it, is almost 4%. And it has gone to virtually every country in the world. Again, if you do have time to go onto my GitHub, do have a look at this graph because they are interactive when you can host them not in a JPEG form. And you can hover over these countries and a label will pop out and tell you the name of the country and how many cases they have. It is interactive. So let's have a comparison. Let's look at these numbers side to side. The case fatality rate, like I already said, is a function of the amount of people who will pass away from the virus as a function of the people who have gotten it. Realistically, the best of a bad lot, probably if we were going to pick one for a pandemic, maybe I would pick coronavirus or the swine flu for the fatality rate. The incubation period, there's nothing so special about the coronavirus that should have made it so different from all these other pandemics. Ebola has the longest incubation period of up to about 3 weeks. The incubation period being from the time that you are inoculated with the virus until the point where the virus is replicated in your system enough to cause you symptoms that will make you sick. However, in that incubation period, before you are actively sick, you will be spreading. So let's have another little look at the confirmed cases and confirmed deaths side to side. Again, like we said, when we looked at SARS, MERS, and Ebola together, Ebola seemed like a pretty hefty pandemic, but it's completely overshadowed by what we're living, the reality we're living at the moment. So what about the last century? In the last 20 years, I mean, surely there's something that can compete with the coronavirus. Any guesses as to what this pandemic is now? Again, it's something that started in the last century, but has come along with us for the journey into the 21st, with 44.5 million people in 2019 living with it, and almost 1.23 million people have passed away in the year 2019. And another one that has equally staggering numbers, the amount of people in 2018 who were living with this particular sickness was over 10 million, and the amount of deaths was almost 1.5 million, and again, in almost virtually every country in the world. What were we saying about going back to normal when the coronavirus dies down? So let's have a look at them. Let's put it into perspective a little bit. Timelines for these. So the timelines that we looked at earlier for SARS, Ebola, H1N1, they were from the time when those sicknesses became pandemic. HIV/AIDS, although there is retrospective diagnostics to say maybe people's remains were tested from earlier than 1981, and it is a retrospective post-mortem diagnosis. The first person who ever walked into a doctor's office and was told, sorry, you have HIV, was diagnosed on the 16th of June, 1981 in the US. Unfortunately, by October of that year, he had passed away, and also by the end of that year, the diagnosed cases gone up to almost 400. Tuberculosis, there is debate about when that originally started. Before the term was coined, it was called consumption, and there is reports saying that we think maybe from the year 3500 BC that has been floating around. But on the 24th of March in 1882 in Berlin, it was finally identified and given the name tuberculosis. So these numbers side by side, again, they make the coronavirus look a little bit easier to deal with. But the reality is, this is not the first pandemic that we have lived through. We have lived through significantly worse and with significantly higher numbers. The ORO score, or the or not score, is the indicator of how many people at any given time you will infect with the sickness or virus that you have while you are infected. So you can see here, HIV/AIDS obviously is a vector-borne disease, so it's quite harder to quantify that because it depends on your own personal habits regarding like unprotected sex, childbirth, breastfeeding, sharing needles. So obviously that can be quite hard to quantify. But tuberculosis, because it is airborne and can get through the air, you could give it to about 7 people, for every 1 person who has it. And again, the coronavirus, like, about 3. By comparison to the other things that we live, really, maybe it's not so bad after all. As you can see here, it's a more graphic representation of the amount of the ORO score, the or not score, how many people that you're likely to give your sickness to at any given time while you are infected. Sorry, the type is a little bit small here, but the coronavirus, I can say really by comparison to some of the other pandemics, you know, not so bad. The only thing about it is we don't have a vaccine for coronavirus yet. We don't have anything that can protect us medicine-wise. There's no antibiotics. There's no antiretroviral therapies the way that there is for tuberculosis and for AIDS. So what do we do? How can we stop this coronavirus entering in that, 44 million people a year are living with it? Surely there's something. The end.
Thank you, Maddie. That scares me a little bit, that numbers. So, any question from Maddie?
I have a question.
Yeah.
Who has their sound on? Me?
I think it's somebody in the
My
class.
microphone is on.
Nice job in terms of visualization and storytelling. Is super cool. Did you do all the graphs and all these nice plots with Python alone, or you were using any data visualization tools such as Tableau or Power BI or something like that?
No, it was all done through Python using Plotly and Seaborn. I didn't use any of the modules to import or drag and drop or anything like. And like I said, I will put the code onto my GitHub because there's some pretty cool notebooks there. But yeah, all the graphs were written in code line by line.
Okay, thanks. Yeah, super cool. Thanks. Congrats as well.
Can I ask something?
A question for Maddie?
Sorry. Was it difficult to find all this data, or I mean, was it easy? Oh, sorry, I'm hearing myself repeated. It's very weird. So in terms of comparable data, because I guess this comes from very different sort of
yeah, there was a lot of limitations around the data that I had in the sense that the method of reporting is not homogeneous from country to country, even though they are all uploading to the World Health Organization. So, for example, there are some data sets that will report the amount of cases per 1,000 people per population. There's the amount of cases in general, this is a number, the amount of cases as a percent in a function of the entire population. Also, doesn't seem to be really a standardized, though these diseases are considered communicable. So if you're a doctor and you diagnose with someone with them, you are obligated by the law to report it to the government. For data sets, for example, around AIDS, especially from about the 90s on, obviously there's some countries that maybe would have a different standard of human rights. And they might stigmatize the population who are generally more vulnerable. And a lot of them didn't report any data at all. And that's absolutely not to say that there is no cases. Additionally, a lot of the numbers are estimates. So they'll have a high level of estimate, a low level of estimate, and kind of a median level of estimate. So you sort of need to pick which ones that you want to use to display your point better. Not that I would ever use numbers to manipulate a point.
Great job, Maddie. Thank you so much, guys. So the next one is going to be Nuria Albo.
Hello, let me share my presentation. So hello, my name is Nuria, and I'm going to present you my final project for the data science course. I'm going to talk you about happiness. And why happiness? Because happiness is a basic need for a human being. happiness also helps us to achieve our other personal goals. Is it known that happy workers are more productive, they are more creative and energetic? And also, there have been studies that relate the happiness with a healthy lifestyle. Studies show that happier people are more likely to eat healthier and do more sport. So let's take a look. My data is extracted from the World Happiness Report, which is a public report that studies the happiness around 156 countries. They do surveys to see how happy citizens perceive themselves to be, extracting a happiness score related also with other variables like the GDP per capita, the social support, the healthy life expectancy, the freedom to make life choices, generosity, and perception of corruption. I focus it in Europe. You can see in the map the evolution of happiness. The happiness score is shown by colors. The brightest yellow is the happiest countries, while the darkest purple are the less happiest. Also, we can see that since 2017 to 2020, it has been a slightly increase of the average of this score. For example, in 2017, we had a 6.06 score for happiness, and in 2020, a 6.29. At this moment, the top 5 happiest countries in Europe are Finland, Denmark, Switzerland, Iceland, and Norway, with Finland with a 7.8 score, and the less happiest are Ukraine, Albania, Bulgaria, Turkey, and Macedonia, Ukraine with a 4.56 score. Have to take in consideration that the COVID situation has not been taken in account for this data. So life expectancy and happiness are thought to be related. In the first place, I checked that the life expectancy for these years haven't changed. And the other thing that I wanted to check was in the data set, the relation between the variables that I got it. And to do it, I create a correlation matrix in where you can see in squares how the data is related. For example, for each square, you have the relation between 2 variables. And depending on the color of it, if it's darker, it means that they are more related. And if it's lighter, it means that they are not related. In this case, for the life expectancy age, we have the variables that are more related to the happiness score, the GDP, the social support, and the life expectancy score. Seeing that I have these relations, I wanted to create some machine learning models to predict the life expectancy. I got the data set and I used 4 different models, the Lasso regression, the decision tree, the random forest, and the XGBoost, to predict the life expectancy. The best machine learning model that performed this prediction was the random forest. As you can see, the real values are shown in gray, and the predicted ones are the green dots, that they are very close to the gray dot. That means that the prediction is very close. On the other hand, the worst model to perform was the decision tree. You can see that the predicted values are sometimes far from the real value. And what about Spain? During these last 4 years, Spain has been in the 15th position in Europe with an average score of 6.36. So it's a little bit higher than the average score in Europe. But how can we improve these results? The second part of my project was to see which applications we have in the Spanish market to improve happiness. I did a web scraping from Google Play, looking for mental health, and happiness, motivation, self-esteem, and personal growth apps. And I got 2009 apps divided in 14 categories, and I got also 902 reviews. We can see that the categories with more number of apps are health and wellness, lifestyle, and entertaining. From these main categories, I wanted to see how people rated the applications. And the good thing was that in the 3 cases, the most number of applications were rated with 4-star or more. In the case of entertainment, the best application were sentences from life and motivation, rated with 4.9. In the category of lifestyle, the best app was Coaching Personal Pro with 4.9. And for health and wellness, I got a Singulo, Guided Therapy, and Lojong Meditation and Mindfulness, also both with 4.9 score. So what about downloads? I checked the downloads, and I got 10 more downloaded applications. Samsung Health with 10 billion downloads, followed by the next 6 applications with 10 million, and the last 3 with 5 million downloads. Samsung Health is a more complete application that has in consideration other aspects, not just the mental health. So I get only those related to mental health to see if there were a correlation between the number of downloads and the rates. And I couldn't really see a strong correlation because there were some apps with a very high rate that had less downloads than others with a less score, with a lowest score, that had a lot more number of downloads. Another part of my project was to do a natural language processing and a sentiment analysis using Vader to get from those 902 reviews, those that were positive. In this case, I got 753 reviews with an average of 176 characters per review, and the negative reviews. In this other case, I got 84 reviews and with an average of 183 characters for each review. What I wanted to do was to plot a word cloud. A word cloud helps us to see the number of times that a word appears in a text, and it shows the word bigger than the others. For example, in my case, for the positive words, I got good that appears 277 times and is the biggest word in the word cloud. Also happens with love, help, and that appear more than 100 times, thank, and excellent. And in the other case, with the bad reviews, I thought that the words that appear more were like bad, audio, error, advertising, uninstall, want. So conclusions and next steps. We have seen that there is a relation between life expectancy and happiness, and that there are a lot of apps that can help us to improve our happiness. This happiness, actually, they are very well rated and with a lot of positive reviews. So I think it's worth to take a look to them. So for the next steps, I would like to get other parameters from the ones that the WHO organization gets to study the life expectancy and study how they will affect in my machine learning models, and also study other relations between happiness and suicide rates or antidepressant consumption. So thank you for listening and be happy.
Great, yeah. Any questions?
Hola, Nuria.
Hola, hi.
Good job regarding happiness. I have a question, just curiosity. Because you were scrapping the apps from Google Play. Were you considering, or did you manage or try to scrap those apps, but from Apple Store?
Yeah, I tried, but it was more difficult.
Vale, that's what I was.
That's what I only get the Google Play website.
Vale.
Yeah, it was harder to scrap them with the method that I was using, the web scrapper. Maybe if I use other methods, that is a thing that I want to try and improve to see if I can get more or from other websites. Because with web scrapper, I had problems with Google, the Google Play Store too, because when the reviews were very long, I couldn't get the full review. Then I had to check it one by one in this case. So,
and yes, another thing that because you are scrapping reviews, reviews and different apps from the Spanish market, let's say, but all of them were in Spanish. But how did you manage to work with Spanish and doing some sentiment analysis that normally deals with and so on?
Yeah, because Vader is working in English, I had to use a Google app, the Google Translator app, to translate all the reviews in English and then manage to process it with Vader.
In Python?
In Python, yes.
Nice. Okay. Thanks.
Nice. Another question? Last one?
Can I ask you something?
Yeah, sure.
Just for curiosity, did you try some of these apps or any of these apps on your own?
Actually, I haven't got time yet to test them because I was doing the final project. So maybe later I will take a look to them. But in some cases, it will be very useful to try them during the project.
Thank you.
So next one is going to be Cynthia. Thank you, Nuria, for your presentation. Great job.
Nuria, estás presentando todavía. Okay. Okay, good evening. My name is Cynthia Palma, and I'm gonna tell you about page speed, what it is, what is important, and how you can improve it. Let's start with the story. One moment. Oh, it's not working. That's not. Imagine something that happened to me some days ago. I ran into a friend, and because I haven't seen in a while, we decided to go for some tapas. And the thing is, I know an amazing restaurant in the area, so just let's go there. When we got to the restaurant, we found ourselves in this situation. The line was so long that we didn't want to wait. Actually, we didn't wait. We just go to another restaurant nearby. Is this situation ever happened to you? And if it happened to you, how long would you be willing to wait? The thing is that page speed and the performance in a restaurant are not so different. If the time is so much that you have to wait, you're going to leave it. You're going to leave the restaurant or you're going to leave the page. Let me show you this with a video. Here you can see 3 different marketplaces and how they are loading. Which one do you think is faster? In my opinion, I would say Amazon, because it shows you the largest content first and also the search bar. But actually, all of them is still loading. So the thing is, page speed is not a single moment in time. Actually, it's an experience that it cannot measure in one metric. So where this is important, what page speed is important. First, we have the impact on the user. User rate the speed, the most important thing in mobile performance. It's even more important that if you can find what you're looking for, if the site is simple to use, or even if the site looks good. So we want things now. We want everything be faster every day. But how much impatient we are? The thing is that if a page takes between 1 to 3 seconds to load, the probability that we will leave this page without doing anything on it, increasing at 32%. And if we add extra 7 seconds to that time, the probability increase and 123% that we are going to leave that page and don't do anything on it. The most critical part of all of this, if we don't keep the user in our website, they are not going to know our product or our services, and in the end, this is going to affect our revenue. So to analyze the situation in Spain, I use the Google Pages Speed Insight, and I extract my data from them using their API. I take the mobile performance of the top e-commerce in Spain. That is 84 different websites. I took the home and the listing page. The home is the main page, and the listing is a page inside of the search. And I took this metric every 3 hours for a week, and Google provides you with field and lab metrics. I did an extensive analysis about this, but for the sake of time, I'm just gonna show you the overall. In the overall, regardless we take the lab metrics or the field metrics, the result is the same. It's a bad result. If you see the field metrics, the real user metrics, most of the half of the user experience go to a website that has a bad or poorly performance. So the situation is not good. What can we do to solve this problem? Before we go to that, I'm going to show you one last metric.
time to interactive. If we go back to the example in the restaurant, time interactive will be the time between you get to the restaurant and the waiter come to ask you for your order. It's the same in a page. It's the time from the page start to load, and finally you can interact or do something in the website. So time interactive is important because it's when you can start to do something in the website. And the reality in the top e-commerce in Spain is that most of the websites, 90%, have a slow performance. To solve this problem, Google talked about making performance budget to establish some limitation. This performance could be different depending on the metric that you choose or the goal or the kind of page that you have. In my case, I want to do a budget based on time to interactive. So to help this budget, I create a model that can predict the time to interactive. And to do that, I train my model with result quantity metrics. This is the weight or size that the page has in kilobyte and the number of requests that a page has. I choose to take this metric because you can predict the time to interactive even before you launch your page or website or the new feeder in your website. So you can know this information before. Between the models that I tried, the random forest was the best, what performed best. So I stick with that. You can see how it occurs in my model. In this second graph, you can see the actual versus the predicted time to interactive. The closer the dots are to the diagonal, is the most occurrence is the model. So this model is performing very well. Most of the dots are closest to the diagonal. And for my model, the most important feeders are the total size of the page, the total number of requests, of course, because it's the overall. Also, the script in size and number of requests. The script is, in simple word, is a programming language. So your computer or phone has to load and interpret that information. It's not as easy as an image that you can load and show. That's it. That's the reason that those take more time. So in conclusion, we can say that e-commerce in Spain has a lot to improve. We can do it better. We can make our website accessible to everyone. It doesn't matter if you have a bad phone or a good phone, it should be accessible for everyone. Secondly, we can say the performance is something that you can plan before. It doesn't have to be something that you have to repair after. If you plan it before, it's going to be better. And lastly, if you do this, you will get an advantage over your competition. If your page is better, it performs better, user is going to stay in your page or prefer your page over other pages. So I invite you to take action, do something. You can start evaluating yourself. You have to evaluate your competitor too. According to your website or what you want to put, you can choose a metric, create a budget, a goal, and you can build a model to help with this budget. And when you finish with this, that is not the end. You can repeat all again the process because you always can improve more. So do you have any question? It was very interesting to do this for me. And if you want to improve your website or evaluate or test it, please contact me. You can contact me in my email, GitHub, or LinkedIn. I will be happy to help.
Cynthia, for me as a UX designer, it's super interesting that this model is super useful. So here's a question from Danilo Velasquez. Of the pages you tested, which one was the fastest and the slowest? The slower, I mean.
The faster was Which. I don't know if you know Which is a Chinese marketplace like AliExpress. and it was in the listing. The main page, it wasn't that fast, but in the listing, when you are searching for a product, it was the faster. And the slowest was ALSA, that is to buy bus ticket. And this is so wrong, because probably you need more to buy a bus ticket, than something from which, so it shouldn't be the other way around.
Nice. I will say that maybe Renfe will be the slowest for sure. More questions?
I wanted to ask something to Cynthia. I wanted to know if you tried this project with new websites.
Yes, I tried my model with other websites with new information, and I can show you here. And with this new, I took 12 different websites to try that are not included in my model, and they are not marketplaces either. And I found that my model has some problems, like, for example, in this one, the difference between the prediction and the page number 10, and the real time to interactive is huge, because this page has media, has videos, and most of the marketplaces or e-commerce, they don't have videos. So I trained my model with some data that is different than this new page. And the last two is the same thing. This last two has a back prediction, because they don't have a script, and all my the data that I used to train my model has a script. So if I want to apply this model to a different kind of website, I have to train it with more balanced data.
Great.
I wanted to ask the same as Oyidia, so I'm going to add another question. Are you considering the possibility of expanding this model that you built, but not for only Spain, let's say, but also using different marketplaces, such as, I don't know, the UK or France or whatever, just to double check that your model, in fact, is a really accurate and really good model?
Yes, I want to try that, but the thing is, the metric could change if you take it from another country. Different. I take it the metric from Spain, because I'm in Spain. If I take it the metric from another country, our metric from Spain is not going to be so accurate, maybe. But I want to, however, I want to try it with new information, and also with more different, like most of the website has a poor performance, so I want to try with very good performance and very bad performance, not like all the same average bad performance.
Good, nice job, eh? Congrats.
Super interesting, Cynthia. Thank you. So next one is gonna be Nuria Romero. Cynthia, can you stop sharing your screen, please? Thank you.
Okay. Can you see my screen?
Yeah.
Okay. So, what? Sorry. My name is Nuria. I'm an industrial engineer and a future data scientist, and I'm going to present you my final project. I'm pretty sure that many of you are users of the visiting of Barcelona, or you have been at some point, and the truth is that this public transport service is in continuous expansion as the city of Barcelona is trying to adapt to a more eco-friendly and future-ready system in which sustainable mobility will play an important role. So in this project, we are going to see the different occupancy trends of different bike stations of Barcelona, and also I'm going to show you different models that I built to predict the availability of bikes from this bike sharing system. So let's get started. Well, for those who don't know what Bithing is, it's the bike sharing system of Barcelona. There are more than 400 stations distributed all over the city, more than 6,000 mechanic bicycles and more than 1,000 electric bikes. And nowadays is a 24/7 service, so you can rent a bike whenever you want through the application Small, but you need to register as a user. I mean, it's not a service for tourists. And the data I used, I downloaded from the Open Data from Barcelona. There you can find a lot of public data. And I used the data for 1 month, the month of October from the last year. And just for 1 month, you have already 3 million samples, because this information is updated every 3, 4, 5 minutes, so you have a lot of data per month. So the presentation is divided in 2 different parts. First, we are going to see the different occupancy trends. We are going to see per station the number of bikes that are available during the day or during the week, and see the different patterns. And in the second part, we are going to see the predictions of the number of bikes for some bike stations. And why I want to predict the number of bikes per station. So the thing is that one of the most annoying things from Bithing is when you want to rent a bike and then you go to the closest station and you see that the station is empty, so you cannot rent a bike. Or even worse, when you are already riding your bike and you are arriving to your destination and you see that the station has no 3 dots to leave your bike. And it's true that the Bithing service gives you 10 free extra minutes to find another station to leave your bike, but come on, it's pretty annoying. So, well, first, we are going to see like the different distribution of the number of bikes per station. And here we have a map of Barcelona, and all these different dots are the stations. So the dots in green are the ones that are full of bikes. In blue are almost full. In yellow, bikes and dogs are available. In orange, it's almost empty, the station. And the dots in red means that the station is completely empty. So here you have the time. We are going to see like the variation through the day. So if I run this, and if I stop it now, we see like, for instance, at 8 in the morning, we have like a lot of stations in the north of the city that are completely empty of bikes, whereas in the south of the city, close to the sea, we have many stations that are completely full of bikes. So this is a problem for the user, of course. And in the plots on the right, we see like the different behaviors from different stations. For instance, the station 331. We see how during the weekend, the station is almost empty the whole day, whereas during the week, you have some bikes available. And in the station 183, we see no difference between working and non-working days. And also we see the distribution through the day. And for instance, this station that was located in the north of the city, we see like early in the morning, the station is full of bikes, but once the people start to go to work, go to the university, the station remains empty. And we have like the opposite situation in this second station. Oh, sorry. I don't know. Okay, now. So here we see again in these plots like the different behavior of the stations. If there is difference between working and non-working days, we see in this one how during the working days we have like this peak during the morning, whereas during the weekend it's almost empty, this station. But we have other stations where there's no difference between working and non-working days. So the second part of the presentation is about the predicting modeling, and I applied two different models, one related to time series using ARIMA, and the other one using a machine learning model. Here we have the results for the ARIMA, and on the left we have the real values, and on the right we have the predictions in red. And we see like this kind of model, it's pretty accurate for those weeks that are pretty similar, but if you have like unexpected events such as protests or holidays, the model cannot detect it. So I apply another model, which is the random forest regression. And here I can add other filters, such as the week of the day, the hour, the demonstration day. But still, we have not really accurate results. And I would say that this is because I need to analyze more data, not only 1 month. So I would need to have like the whole year, or maybe the same month, but from the previous year. So as a conclusions, I would say that the availability of bikes strongly depends on the hour of the day and on the altitude of the station. And some stations also show a big difference between if it's a working day or not. And for the predictions, ARIMA, it's pretty accurate when you have like similar behavior during the different weeks, but doesn't take into account very important features. And for the random forest regression, it wasn't really accurate, but I think that I can improve it by analyzing more data and also adding external information such as the weather or other features. And as a next step, I want to improve this random forest regression model. And also I want to perform another model, which is a classification. And instead of predicting exactly the value of number of bikes, I want to classify the station in these 5 clusters, which is full, almost full, bikes and dogs available, almost empty, and empty. And thank you very much for listening. If you have any questions.
Bravo, Nuria. Some questions? Questions? Idoia?
How long did it take to train these time series and so on, and to learn how to deal with time series? Because time series, as far as I know, it's not part of the theoretical concepts that we normally see in the course.
Yeah, well, it took time to understand well, because sometimes you expect some results, and then when you try the model, it's a mess. So, well, I've been doing a lot of research, and also thanks to you, because you were helping me as well. But in the end, okay, I think that the model, it's not pretty accurate, but because time series works like that and cannot take into account like unexpected events. So
yes, that's another thing, no, that I think it's also interesting to highlight, that you are dealing with a data set from October in which all these demonstration and these violent things took place. So for sure that the patterns were not like the typical ones, unfortunately. But I mean, you can do it with some data set or data from November or September or something like that. Now that you will be more free of the classes.
yeah, I can try like with more normal months.
I want to see them. Nice job, nice job.
Thank you.
Thank you. Next one is going to be Valeria.
All right, 1 second.
So Nuria have to stop sharing her screen. Nuria, could you stop sharing your screen? Oh, there you go.
All right, you can hear me?
Yes. Perfect.
Oh, you can, yes. The rest. All right, so I'm gonna tell you today a secret to choose some foods that are actually good for you. But before I get into that, I actually would like to tell you a little bit about myself. I know that most of you know me really well by now. Maybe not so well, but but somehow. But anyhow, my name is Valeria. I'm a health enthusiast in general. I'm also a hotelier, ex-recruiter, and now I'm a data scientist, a proud one. But there is one thing about me that actually is my passion that also makes people turn around on the street, ask me questions at 6 a.m. in the morning and try to figure out what is that I'm doing. And that's because I really much enjoy doing a fitness that is called Kangoo jumps. So these boots that you can see on my feet, they help to protect your knees. They were designed by the Swift, and I really much enjoy that. Yeah, but that's enough about me. Let's get back to that secret that I was talking to you about before. So what I was talking about, there's something that is called Nutri-Score. It is actually a formula that was developed by French in 2017, and it helps us to calculate, say, how healthy the product is. It has 5-color nutrition label from A to E, from green to red. Green being the healthiest product, and E being the least healthy product. I won't get into details of how the formula is calculated. In general, it is basically rating the most of its ingredients, so energy, fat, sugar, carbs, saturated fats, and so on and so forth, to then say how healthy and how the product is. But regarding my project, what did I do with that? Obviously, the Nutri-Score existed, but not for all of the products that we have in the market today. So what I wanted to do is I wanted to find out if I can build a model that would predict it for the products that are not labeled yet. So for that, there are 4 main tech topics that I touched and that I used. One of them is computer vision. So there is a TensorFlow model that helps to predict, to find objects on the pictures. I used the Google Vision API that helped me to detect the text and the numbers on the pictures and on the objects that were previously detected by the computer vision. And I have used the NLP model to then basically sort out the language that was detected on the pictures. And finally, I've built a predictive modeling to basically put together a Nutri-Score of the products that we were looking at. So let's take a closer look at how everything works. Yes, that is me. So I was there in the Mercadona supermarket taking pictures of the products like a creep, but it worked out pretty well. So here you can see how the TensorFlow has detected basically the nutritional label. There's another example over here. So basically it selected and puts it in a box, which is then cropped. And then with the Google Vision API, I was able to extract text by sentences, by the blocks, which are the blue labels, and then by the words, which are the red boxes. And same we can see here for the product, also did separate the numbers for me. So after that, I could get some results by the predictive modeling. So there is some magic and the prediction behind that. Girls had talked a little bit before, so I'm not going to get into that details. But here is something that you would get as a Nutri-Score of the label. And this is the product that is a little bit controversial, probably, if you see the Nutri-Score and you see the product itself. It's a natural cashew nut, or not a nut, whatever you prefer to call it, some don't. So it does have a score of C, which is kind of not so healthy for you. And that's controversial because you would think that a natural product that doesn't have any salt, it doesn't have any added sugar, it's just a natural sugar that it has, But it does have this C for the high quantity of fat that it has, which is natural for it. It's one of the fattest nuts that we have out there, and the natural also saturated fat. So let's see, what do you think about the product here? Everybody, loved by everybody, Nutella, what kind of label do you think it could get? So yeah, not controversially, very clearly, it gets an E, well deserved for the high amount of fat, of sugars, of saturated fats. Let's move next then. How about the asparagus? Anyone likes it here? Do you think it's a good one? It is indeed, as I thought. I mean, it's vegetable. There's nothing in it. There's a little bit of salt added to preserve it, a little bit of sugar, but it's really at a low amount. Last one. How about Coke Zero? What do you guys think? Very close enough. It's a B. It's something that had been posted a lot of.
CC wanted you to check this.
We'll do that later. I have a bottle here. So yeah, it's very controversial. Coke Zero has been all over the place in European newspapers and magazines, saying that how is it possible that it gets this B label of Nutri-Score? Well, right, if you look at the nutrient levels, there is no fat, there is no sugar, there is no saturated fat, there is almost no salt in the product. There's something you're forgetting about, and that's my next point, and that brings me to my conclusions that Nutri-Score is great, and I'm very happy I could calculate it for the products that were not there. But we cannot base our decisions solely and purely on Nutri-Score, because there's many more things in the products. For example, like Coke Zero, it's highly processed food, and we need to take that into consideration. So that brings me to my takeaways and my main points of the project. Well, first of all, of course, data science is in our daily lives. It's not something that is only scientific. It's in our food. But we need to make sure that we have common sense and we take into consideration not only something that has been calculated by data science, but also things that we might already know about foods, and think twice before looking at the labels that are out there. Also, yeah, my main topic, let's say, of the project, and something that was completely new for me after the course, because we have not touched it, was computer vision. It is a very green, very complex concept. It's another world of machine learning, but it's very much worth diving into. So I do recommend to all of you who are going to do data science or continue data science to dive into it. It's absolutely amazing. And of course, that all models are wrong. We've probably seen that by now. It is also that in my case, there were many products that were not correctly classified, or as I said, there are many more things to take into consideration when you were looking at the food product. So of course, I will not stop here. This is only the beginning for me. I have just opened the page of computer vision, also data science. Thanks to the Open Food Facts database, I was able to analyze and compare the products that I took a picture of with the ones that they already have in their database. If you're interested, please take a look at it. They have more than 1 million of products that I was working with in their data set already. Some of them labeled, some not, but very interesting to look at. And yeah, that's for me. Do you have any questions?
Oh, amazing. Any questions? Oh, sorry. Oh, no.
I know you showed a picture of reading the labels even when they were a little bit kind of crinkled and stuff. How did you find really gathering the data and the computer vision actually for that many labels and different textures? Or was there a type of plastic that you could never get the shine off, or how did you find that?
Yeah, that's a really great question. So Mehdi, thank you for that. Let me get back to one thing. Certainly, there is, the picture has to be, I'm not gonna lie, the picture has to be taken in a good way. I was able to, so if we go back here, you can see on this cashew package, there was like kind of light there. And I was able to still detect the number from here. So the Google Vision API does pretty good job on seeing like folded numbers and read the text. However, it is completely true that even on this picture here, it deals with text. So we see two boxes. And if the picture is slightly, actually deals really nice with the pictures that are not very clear, but if they are turned, or if there is a glitch like here, and there is like lots of shine, it probably won't be able to read. So you do need to take care of that. Anyone else?
You? Yes. No. How long did it take for you to like understand computer vision and so on? Because it, as far as I know, is not part of the, how's it called, of the course per se, no? And to deal with images and in terms of time consuming, or time consuming, no, time of execution and so on.
Oh yeah, that's a whole new world. As I said before, it probably took me first 2 weeks out of 4 that we had for the project to just get to understand what is it all about, because the concept is completely different, the picture is read in a completely different way, and that's something that you need to understand, and it's definitely something I'm gonna continue working on. Also, it does true that it takes a huge amount of power to process the images in the model, so I wasn't able to actually make a huge prediction today. I had to try to connect with I connected with the Amazon Web Services to see and try to execute my model there, because my computer was not strong enough for that, and that's something else you should, and I will take in consideration in the future if I'm planning on working with pictures. It does require a lot of memory to run.
Super. Congrats, nice job, eh?
Thank you.
Nice, Valeria. Next one is going to be our co-founder, Cecilia.
Hello. Here we go. Can you guys see? Yes? Okay, yes. So, well, I am said co-founder. My name is Cecilia. I'm just another Earthling. I'm going to present something slightly different from the rest of my classmates. I want to share a little bit this is like a learning log, the last 4 weeks. And I'm calling it To the Moon, because this has truly been kind of the out of the world experience for me. So here we go. So, you know, this whole all women kind of initiative started when Laura and I had this conversation, and we realized that there is a problem. We were looking at different search terms in Google, and we discovered that, for example, if you search secretary, you will see this, and a lot of times it's not exactly representative of what secretaries are, and even, you know, the gender ratio, right? So we all know that maybe the term secretary is not in use anymore. So we looked up other terms like personal assistant, and even so, we see most of them as women. And it started. We started to think about how representative this is, the digital world versus the real world. And to look at the other spectrum, if you looked at CEO, obviously, as you know, as we all know, it is. Mostly representations are men, and so wanted to be equal in both spectrum. I also looked up, you know, firemen, another profession, to see if they're equally represented. And I'm actually happy to say that there are some inappropriate images of firemen as well. So in that realm, I'm happy to say that there's some representation. So Why am I interested in this? I'm interested because I wanted to start with this quote by Robert E. Lee. He said, "Get correct views of life and learn to see the world in its true light. It will enable you to live pleasantly, to do good, and when summoned away, to leave without regret." And so thinking about this even more, if computer vision is in a way an extension of our human capability of understanding the world, being able to capture that and being able to look back on what it is giving back to us will be a tremendous ability for us to see the world beyond what we are capable of. And so I wanted to take on this journey in the last 4 weeks to learn more about computer vision. And so I started taking classes, and I started to talk to a lot of my mentors, Idoia, my professor, Noemi, computer vision expert. I talked to Guadalupe. And first thing they told me was that I need a lot of data. Well, exactly how many data points? Well, I was told that I need at least 35,000 faces to be able to start analyzing and doing models. And that was exactly my look at that moment when they told me that I needed 35,000 faces. Okay, so where in the world am I going to get 35,000 faces and data points, right? So I searched and searched, I looked and looked, and I asked around. Well, as we all know it, the internet is the best source of data. And we have these massive platforms like Google, Facebook, Amazon, where we can start looking at some of this data points. And so I picked LinkedIn because I was very much interested in their profiles, and I also most interested in how they represent those data. And so how do I go about looking for data? With some help with Idoia, we managed to, well, first of all, I had to set up what exactly am I looking for. And so I set up 3 levels of search. The first one is cities, and there's 10 cities, all American cities. The second is the different levels or roles within LinkedIn that I want to search. And the third one is the department. And within those 3 different areas, I made all of the possible combinations there is. And with that, I have 330 queries, and that I send it to a bot, and you can see in this video that it's magically doing the scraping for me of all the LinkedIn profiles. And so with that bot, I managed to scrape 31,481 LinkedIn profiles in 4 hours. And also with another bot, I managed to scrape 7,000 LinkedIn photos along with their name, job titles, and description in 12 hours. I was already blown away. I was already ready to present my project and be done with it, but I did it. I kept going on. Before you say that is this even legal, well, I checked, make sure that what I was doing isn't breaking the law. And in fact, it is legal because this is public data. These are public profiles. And so using public profiles via LinkedIn platform, it is legal in terms of the law by the states, but it might not be contractually with LinkedIn. So you do have to be very careful in terms of what you decide to do with those data. And so moving on to the next step was that I have to learn a new module called OpenCV, which stands for computer vision. And so I took a course, and there has been already some modules that I could use as a baseline to test out face recognition, because I need to understand if there's even a face existing inside the pictures that I've downloaded. So I tested this with my kids and even my dog, and miraculously it worked. So I'm really happy with that. And so the next thing that I had to learn is to understand not only that there's a face, and not only that recognizing a face, but that there are these specific features, eyes, nose, mouth, ears, and so forth. And so with that, there's another library that I've used. And I managed to, and using another tutorial by this guy that I highly recommend, I managed to do this. I am actually going to run a live, I don't know if this is working. Can you guys see? Okay, so I managed to make it running. So you can see how it is detecting my facial features. And I'm like pretty much blown away at this point at some of these modules that I was able to follow. So the next step in my journey is to learn about what's called convolutional neural network. And I was like scared out of my pants. Just hearing those three words, it sounded super scary. But but breaking it down, it is a subset of artificial intelligence inside machine learning and within deep learning. This kind of understanding of how neural networks could be applied. And so in a very, very kind of overview of what neural network is, if you can see on this side of the chart in orange, what it is that you have these hidden layers, and that you feed a training data set in it, and what it does is these different layers, the first layers will look into a specific detail, and then it pulls the resolution out until it is in the kind of a larger understanding of what that item is, and then it will classify in the different things that you have labeled. And so this is in a very kind of an overview of what neural networks and convolutional neural network works. So Noemi, one of my mentors, also suggested that I take a course on TensorFlow for deep learning, and that took a while. Actually, I did that with my boyfriend who's sitting right next to me, and that was like our Saturday night instead of watching movies, our Saturday night pastime. So there also, miraculously, are these amazing modules that I could use as baseline. And so this one is face detection for multitask convolutional neural network. And I made a first trial run with my daughter, and it worked. It detected the face, and it detected the features. And so the next step in my journey is to run all of that data that I have scraped and compared it to see if there's clusters amongst them. And so I created two data sets. One is called the data set of all the CEOs that I have downloaded, and the other ones are the allWomen profile data set. I'm sorry, I used you guys. But there's a CEO data set and there's an allWomen data set, and I ran a distance matrix to see if they could find the distinctions amongst them. I don't have conclusive results for this. This was more of an example of for me to understand if I could run the two separate data sets. So this was as far as I got in the journey over the last 4 weeks. I still need to go back and complete the data set to arrive to 35,000 data points. But what's really interesting for me is that as we are kind of moving forward in this digital realm, where we have this digital world that is overlapping with our physical world, but at the same time we're finding discrepancies. I really wanted to apply this new skill set in my work, which is in the Futurity Studio for Equality and Gender Lab. And so moving forward, I wanted to apply what I have learned into three follow-up projects. And the first one is I wanted to look at how Google search results are representative or not to the real world, and if not, quantitatively how different. And I also wanted to do the same thing in LinkedIn because if LinkedIn is showing results that are different from, say, its user demographics, then maybe we can identify some bias in the algorithm that we could suggest to LinkedIn for a performance upgrade. And the last thing I really am personally interested in is I wanted to learn more whether there are correlations of facial features to hireability and job opportunities. And so on the right-hand side, you can see an interesting project by Stanford Social Perception Lab to understand if a certain facial features are considered more competent versus others. And so that's it. I have gone to the moon. I have came back, and I am now ready to apply everything that I have learned, all my superpower, thanks to my co-founder, and thanks to Idoy, and thanks to my classmate. And moving forward, I want to apply this to impactful changes. So thank you.
Bravo, Ceci.
I have one.
Did I have one?
Yes. Cici, Didn't you have any kind of limitations in terms of, well, you were scrapping the URLs and so on, Google, because I know that Google sometimes it gets you some catchas because you were creating a boot, come on, a boot, something automatic, you know? So I have the feeling that maybe you had some images or some catchas or whatever.
I had a lot of Google only limits you to do 100. If you're using a bot, it limits you to 100 search results in return. And so for every query you send out, it will only hit back 100 items. But the workaround is to use VPN. So so the way that I set it up is that for every query, so I have 330 queries, and each of them returns 100. So I calculated that it will give me more or less 33,000 items back. And so for every 20 queries, which gives me 100 items, I switch VPN, and that's the maximum. Before Google said, no. And so I managed to work around it with every 20 queries changing VPN. And apparently there are bots that can help you automatically change VPN as well. So there's always ways around finding.
That's the suggestion that I have to try for the following weeks, to try to create this automatic boot, because then it did automatic changes and so on, because then it will be like super hacker.
Yeah, definitely.
Very nice job. Very nice job. Congrats.
Thank you.
Next one is going to be Georgina.
Okay, so I'm going to share my screen. And hi everybody, I'm Gina and I'm going to talk about gender gap in cinematographic world. So let's start. I'm here from Barcelona and I'm finishing my studies in computer engineering. And I started this course because I was interested in know more about this new and interesting field. So why I chose this project? One day while I was seeing Star Trek Voyager with my father, I realized that most of the female characters were playing roles that historically were played by men. For example, the captain, the machine engineer, the astrophysics that calculates the spacecraft route, and the leader of a powerful species. Maybe during these last years, the gender gap has been closing, but I want to check more films and TV shows in order to see if there's a pattern. So I scraped the data for my project from Film Affinity. That's a webpage for voting and recommending movies and TV shows. And I get details like the year of release, the country, the directors, the cast, the genres. But while I was to check the gender bias, I used an API called Genderize that gives you the gender of a first name. So here you can see the example with my name. And I use this tool to detect the gender for all the cast and the directors of my movies and TV shows. So from here, I start working with more than 2,000 movies and TV shows. Let's see some results. I structured my data in 3 different ways and analyze it by doing an exploratory data analysis, a sentiment analysis of the reviews, and an image analysis of the covers. Let's start with exploratory data analysis. You can see here that during the last years, the gender gap has been closing. You can see it clearly here in the director's case. But if we take a closer look to the most popular countries, we can see that the picture is not as good. Only Colombia has a higher rate of females versus males. And if we take a look now to the cinematographic genres, we can see that the picture didn't improve. And here we have some cases in the direction graph where the male presence was 100% versus the female one that there was no presence of female in animation, action, or crime, for example. So finally, if we take a look to the most common gender of the movies and the TV shows, we can see that only a 10% has female presence, both from directors and cast cases. So let's take a look now to the sentiment analysis of the reviews. The aim of this analysis was to check if there was any difference in positive or negative reviews for the most common gender of each movie and TV show. I used a natural language processing tool called Vader. Don't worry, I don't plan to blow up any planet, not yet. And here we can see some results. Fortunately, the results are positive. There's no significant difference between positive and negative reviews from both genders. So I take a look to the top 20 most used words in these reviews. And for the positive ones, I found that the word action is used only in the male reviews, while for the female reviews, there were words like life or moments that were used only in those cases. And I did a little bit research on my dataset, and I found that maybe this is correlated with the cinematographic genres. And for the action films, the most common gender is male. And for the documentary or the quotidian films, the most common gender is female. So maybe that's the reason of that results. Finally, to finish this analysis, I did an image analysis of the covers. I analyzed the 5 most common colors using computer vision for each cover from my movies and TV shows. And I classified them into a group of colors in order to compare the most common genders. So for the cast, we can see that the most used color is cyan, whilst for female is purple. And if we move to the director's case, we can see that the most used color is red, and for the female ones is orange. So finally, I want to show you some of the most popular covers. For that ones that the most common gender was female, we can see films like Matilda, The Prince of Bel-Air, Annihilation.
Aquí tienes lo que he encontrado en internet.
Or How I Met Your Mother. And for the male's case, you can see The Lord of the Rings, Matrix, Forrest Gump, Pulp Fiction, and finally Kill Bill. So my conclusions were that I have imbalanced data. So maybe the results could be different if I had more years or more countries to analyze. Maybe time shows that the gender gap is closing, but we see that in countries and cinematographic genres, the difference was really high between both genders. The positivism or negativism of the reviews is not affected by the most common gender. And despite the fact that there are maybe 1 or 2 colors that are more used for one or another gender, there's no significant difference. So what's next? I can try to find more samples in order to obtain more equal results. I will try to explore if there's any difference for countries regarding the positivism or negativism of the reviews, and try to apply the same analysis for the synopsis of the of my movies and TV shows. And finally, maybe I could try to find some faces or objects in the covers of the images and classify them by gender, and maybe try to compare the countries or the cinematographic genders. And that's all. Thank you for listening. And if you have any questions.
Thank you, Georgina. Any questions? Let's see the chat. I'm sure Ida you have.
Which was the most, congrats, first of all, really nice presentation.
Thank you.
And so on. Which was the most difficult part from your project? I would say maybe getting the data or building or arranging the data or using the gender gap or building a plots? Because
yeah, I think by far getting the data. It takes me a long to get the data, to web scrap everything, because I was having problems with the CAPTCHA thing too. Yes. But yes, it was hard to me to plot the results, because I was like, I don't know how to plot it and how to show to the audience the results that I obtained. But yeah, the worst part maybe it was obtaining the data.
And arranging everything, no? Maybe?
Yeah, and translating the things and obtaining the gender from the cast and the directors. It takes me so long to prepare all the data in order to make the analysis.
Yes, because the reviews and so on were in Spanish or in different languages?
Yes, whereas Nuria were half in Spanish and half in English. So to train the Vader model, I need to translate them all in English. So I used the Google Trans module from Python, and with that, I was able to obtain everything in English.
Very cool. Congrats.
Thank you.
Next one is going to be Ogidia.
I hope you can hear me well. If not, just let me know. So, good evening. My name is Oyidia Ojipalino, and today I'm going to present my point of view regarding microfinance institutions. My goal is to let you know that there are many things that are running in the countries we call undeveloped, and because they have many kinds of projects that are really interesting and that they are really running by themselves. So the thing is, in this case, what is a microfinance institution? From my project, I could just state that there are organizations that provide financial and social benefits to its borrowers in order to develop the capacity of small groups of people to take control of their lives. When I'm talking about organizations, these could be enterprises, other kind of institutions, NGOs, and also banks or branches from important banks or European or American banks. So I also wanted to state the evolution of the Mfis, just to let you know that this is something that is really new. It started in 1974 by Mohamed Yunus, which was a professor who wanted to lend 24 euros, or the equivalent of 24 euros at that time, to a homeless person in Bangladesh. From there, he continued by founding the Grameen Bank, which is one of the biggest banks at the moment regarding Mfi. And this was in 1983. And then from 1997 to 2002, there has been a really good increase of Mfis and its presence in many communities. And also in 2006, Mohamed Yunus won the Nobel Peace Prize for this project, for the ability to provide microfinance credits to people who come from countries with difficulties. So the thing is, what is going to have to be in 2020 with this COVID situation at the moment? So in order to work with my project, I worked with data from 123 countries, based in 7 regions from more than 3,000 organizations. And I wanted to study 17 social policies and compare them with 10 annual barometer reports. So where are they located? From this interactive map that you can see from 1999 to 2017, you can see that the presence of Mfis has been rising, and the darkest colors, the darkest red means the highest is the presence of this kind of institutions in the world. So, which is the Mfi density? We can see that the top 3 countries are India, Peru, and Mexico, and that the top Mfis regarding the number of borrowers that they have are coming from Bangladesh and India. So, and what do they do in terms of loans? In terms of loans, the average of money that they are running is $230 million per year, working with more than 90,000 borrowers across the globe. And the most important thing is that almost 50% of these institutions are concentrated in Southeast Asia. Also, I wanted to check the ratio between offices and the number of people who are working on those branches. And I could see that 9 people are working for every branch. And also what kind of interest they were working with. Most of them, the 64%, were working with declining balance. Which means that the interest is paid the highest amount of interest at the beginning of the contract, and then in the end, it's just a very little interest that the borrower is paying. And also, there's the 36% of platinum, means that by the whole term of the contract, the borrower is paying the same amount. But of course, this kind of conditions can vary. Just depending on the agreement between the bank or institution and the borrower client. So, in order to do a classification, I used 2 machine learning models, and I wanted to state the relationship between offices and borrowers. From this part, I could see that a big amount of institutions had a medium size of borrowers and many offices. This was just like the normal trend generally, but also there were other companies having few borrowers and few offices. And last but not least, I could spot also many borrowers with few offices. And maybe I was thinking that this was because of the increase of the internet access, making that it was not so necessary to have a lot of offices in this case. So I wanted also to state, why are they so important in this case, these kind of institutions? Well, the thing is that their goal is to have clients from low-income population, which are people who are probably in conditions of poverty, even extremely poverty. And the goal also is to acquire or to have at least 80% of the borrowers as clients, being from 65% from rural areas. Another thing that one of the other aims that they have is to educate in terms of health and gender and women empowerment, and also to give financial education to their customers in order that they understand better what kind of products they are signing. So, regarding social impact, which was something that I was really interested in studying, I could state in company they had a very good packages for their employees. For example, they were giving health insurance to them, also giving them education regarding gender and empowerment, giving them pensions, and also they had programs related to harassment. And regarding local communities, of course, they were continuing educating in gender and empowerment, giving loans for startups, also for livestock and agriculture, and also also focusing in education for adults and youngsters. So I continued just trying to compare what I studied with what the annual barometer reports were giving me. And for this, I extract the last year's publications in PDF, and I extracted the key words that they were using them the most. You can see them by a word cloud, which I was using with NLP. A word cloud is a system where you can see the frequency of the words and the importance that are given in each report. So you can see, for example, in 2017, that one of the reports was stating a good or higher importance, for example, to Europe, when we could see, for example, that previously in the map, Europe was not appearing. Also, for example, in 2018, they were talking about Africa, but probably they were talking enough about Africa in terms of a continent or a country instead of talking about the countries itself individually. And last but not least, they were talking about the presence of the mobile or the technology in order to have like better communication with their clients. So, in order to continue with my work and with the project, I was thinking about which could be the steps to follow. For example, I could follow just the time series model in order to detect the growth, the trends, and maybe, who knows, if I could just spot some kind of stationality between organizations. Also, for example, I could add stats from the last 2 years, from 2019 and 2020, and see how COVID is affecting the MFI's priorities in this case. And also, I could also try to understand how the top 5 MFIs are promoting their policies and how they are performance, and maybe try to build some kind of KPIs. So my conclusions for this project is that the impact of MFIs are difficult to measure because you can measure them in, for example, in a financial way or a social way, or maybe more, or maybe you can use other kind of parameters to measure them. Also, I see that it's a very important to track social and financial policies in order to help more communities and try to develop at the same time, or to grow the institutions and the communities at the same time. Also, it is good to understand the borrower's needs because no one is equals to another one. So because of this, it's good to adapt the products to them and to understand why they are needing these borrowers. And also, for example, it's good to have boarding members with relevant experience in order to implement social policies that can make a better understanding of how these are going to impact in the community. And of course, policies that may be for sure in now, currently, and in the future are taking climate change. So I hope you enjoyed my explanation about the Mfis, and just let me know if you have any questions.
Let's see, there is a question in the chat. Yeah. Go for it.
No, you were saying that you were doing some models in terms of machine learning, but how many models did you use or train or manage to like make it work and so on? Because it's interesting to share.
Well, first, in order to detect which variables were meaningful for me, I started with one, which was random forest. And from there, maybe I used, after I used unsupervised machine learning, trying to use one that was not working at all and another one. So I used 2 models for unsupervised in order to detect the clusters. And after confirming them, I used maybe 7 or 8 models in order to detect which one was better to classify them and to confirm that the clusters I spotted before were correct.
And which one was the best that gave you like higher accuracy, or the winner, let's say? Just for curiosity.
Well, say that there were many winners. I would say there were top 3, but for example, logistic regression was the one that was giving me very good results. And well, that's it. I would say logistic regression was the best one.
Very cool. Congrats.
Last but not least, is going to be Daria from Madrid.
Can you hear me?
Yes, perfect.
Perfect. Sharing my screen now. Wow, the last presentation. I'm honored to close this demo day. Okay, can you see?
Yes.
Perfect. So yeah, I'm Daria, and as my final project, I decided to explore Twitter data to understand better the current political situation in Belarus, my home country. And previously I had the idea to analyze Twitter data from Black Lives Matter, but since then, the events in Belarus started to unfold in very, very ugly manner. So I decided to switch my focus a little bit. So the context of my research is the following. Alexander Lukashenko was democratically elected in 1994, and he's been the president for more than 26 years already. He's a persona non grata in European Union and the US for human rights violations, kidnapping, and disappearance of political opponents, and constant power abuse. So the new presidential elections are planned on the 9th of August this year. Lukashenko wants to be re-elected, of course, for another 5 years. It caused countrywide protests and basically unseen wave of solidarity. And right now, right here, peaceful protesters are facing unprecedented repressions. Politicians, activists, and journalists are abducted in jail without any charges and tortured. Some people, including some friends of mine, are forced to run from the country in the night through the forest. And the very interesting thing is that independent sociological surveys are basically forbidden in the country, and there's no way to learn about the real rating of the president and the candidates. Some internet surveys suggest that Lukashenko has the support of no more than 3% of the population, while publicly claiming 76%. So my data science goal was to measure the real loyalty of Twitter users, track the reaction of international community regarding all this situation, and identify key hashtags and topics. So the first step was to get the data from Twitter. So I managed to scrap approximately 160,000 tweets related to Belarus and the candidates, starting from the very beginning of June. And I've got tweets in 49 different languages with 3,500 daily tweets on average. And here's the plot. Since June, and there is a very evident spike on June 19th. And that was the detention of Lukashenko's main political opponent, Viktor Babarika, and his son, Eduardo. And this is the most liked tweet coming from a user, Tomato Hater. And it's basically a description of the situation around the presidential candidates, that Babarika is arrested with no charges, and Svetlana Tikhanovskaya, who's the only female candidate right now, is actually threatened with abducting her children. So the next thing for me was filter and spam, because there's a lot of junk on Twitter, and half of this junk, surprisingly, is BTS bots that are tweeting the charts in every country like every minute. So I manually labeled around 2,000 tweets, if it's spam or not, and I built a machine learning model to detect it. And after applying this model and some manual cleaning, I managed to get rid of only 4% of data, unfortunately. It wasn't enough. It was still a lot of junk in my data set, but like I would need to spend like the week of labeling all this data in order to get better machine learning model. So I decided to move on with what I have. I used an NLP library called Spacey, and I filtered tweets related specifically to Lukashenko and his main opponent, Babaryka. And as you see, Lukashenko has more tweets and more mentions in general. And what surprised me a lot that the sentiment analysis has shown that tweets mentioning Babaryka are way more negative. And I decided to look into specific tweets to understand why so. So the most negative tweets mentioned Babaryka is about the fact of him being arrested and accused like with like false accusations actually. And the next one, the most positive tweet about Lukashenko is actually irony, like €350 average salary, great little Lukashenko, better tomorrow. So NLP does not read irony, unfortunately, just like Sheldon Cooper from The Big Bang. And another supposedly positive tweet is some girl is asking Donald Trump to support the people of Belarus and get rid of Lukashenko's regime. So very positive. So those are main hashtags related to both candidates. While there's almost no negative hashtags related to Babaryka, there are plenty of them related to Lukashenko. And this is a topic modeling. I did it with LDA. So again, there are plenty of topics like dictatorship, protests, regime, while Babaryka had opposition, intimidation, arrests, accusation in money laundering, along with Gazprom and Gazprom Bank, which he was at head of Belarusian branch for 20 years. And actually what surprised me the most is that in Lukashenko's data set, Elon Musk space and spacesuit popped up. And I was like, why? So that's why people actually massively writing to Elon Musk, asking to launch Lukashenko into a space without a spacesuit. And also to test his project Starlink, the satellite internet on Belarusians, because Lukashenko is threatening to block the internet. So what about international feedback, international community? Do they have any opinion? So using the same Spacey, I divided tweets into US related and European Union related. There are clearly more US related tweets, although most of them are not quite related to politics. And unfortunately, I didn't notice any high officials expressing their position regarding the situation in Belarus, except the US embassy in Minsk. And there are fewer European Union tweets, but the position, I would say, more daring. For example, the most retweeted post was by Donald Tusk, strongly condemning the behavior of Belarusian authorities. So the brief conclusions are that Twitter users show no support for Lukashenko whatsoever. Even positive tweets are mainly false positive and ironic. Babaryka, negative sentiment of tweets is related to his name being mentioned in the context of arrests. And well, there are more US related tweets about Belarus, but more decisive tweets come from European Union officials actually. And of course, we could build better machine learning models for filtering spam. While I was researching this topic on protests and Twitter, I found a very interesting article in Nature explaining the correlation between moralization and the emergence of violent protests. And it would be actually amazing to build an app with real-time predictions of violent protests by identifying the percentage of morality and ethics in tweets and matching it with tweet allocation data. And the background video that you see right now is from yesterday. So the violence is already happening on the streets of Belarus. And well, yeah, the people actually are not afraid to fight back. The key question for Belarusian people right now is how many people are ready to go on the street defending their basic human rights on the day of election. And I encourage you to stay tuned and follow the revolution online on Twitter. Yeah, this is me, and this is it. So would be glad to hear your questions.
Thank you, Daria. This reminds me my country, the same situation. So I'm sure your application will work not just for Belarus, but for a lot of countries. That it's
yeah, I'm sure about that.
Any questions? Idalia?
Yeah, I think it was a really cool project. I mean, of not only like the data science part, but also like spreading what's going on in Belarus. Because, for instance, in my opinion, my personal point of view, I didn't know about that. So it's really cool to spread to spread the news, let's say, or these events, and also using data science to achieve that goal is like top, let's say, no. But I mean, pretty cool. I'm super proud.
Thanks.
And really nice. Yes, I don't know, like no say no questions because I think you explained it super cool and you did it nice as well. But no.
Thank you.
I can't wait to see the machine learning model with the spam. I mean, with the see that.
I'll build it.
We congratulate you all that after 10 weeks of full-time, 8 hours, going remotely and then doing the flexible learning environment here to come into the mob for some of you. And also congratulate Idoia, who is just amazing teacher, doing a great job during 8 hours forward. So great job. I'm super proud.
I mean, it was easy with that. Everybody was like super motivated and willing to learn and so on. So that's a good combination. I would say a good combination between motivation, intelligence, and the data science course that allWomen is giving is like top, no? Like a rocket, let's say. So we can give you the wings and it's time to fly. Let's say. Fly. Congratulations, ladies.
Some words for Idoia, come on.
Thank you for all the coaching, Idoia. Not only for teaching us, but for all the coaching.
Yes, for the energy and the motivation and being there for us at all times.
For your patience, because you had a lot of patience with us.
Bueno.
Thank you, guys. Thank you so much. It's been amazing.
Exactly. That's the beginning. Really beautiful.
I was listening to your presentation for the last slide, and I was telling them like, we should hire all of us. I'm sorry. I swear. And I also get a bit emotional every time I see these presentations, you know. Seriously, but it's super smart, in such a short time, like starting from zero. No, it's really impressive, I must say, yes, it is. I'm doing the course right now and I'm suffering. I feel like, well, okay, maybe I can achieve that at some point, you know, so it's motivating to see you.
And if I may just say one thing, I think this particular edition, I mean, it's special for me, obviously, because I'm in it. But I think it's super special because at the beginning of it, we started in April. There's so much uncertainty. COVID was starting, the lockdown began. Some of us had to homeschool our children. There was a lot that we didn't know how to deal with. And so for me, I didn't even know if I was gonna make it through this 10 weeks. And so somehow miraculously, with the patients of Igaya, with everyone's organization, the fact that we pivoted so flawlessly online, thanks to everyone's, it worked. And so I wanted to say, thank you. It is, when I say I've been to the moon and back, I have literally went to the moon, and it has been amazing. So thank you.
Well, we can just disconnect here. I'm sorry, Daria, that you are not here. We wish.
Please come one day. One day you manage to come to Barcelona for that. You can just come here and we can share a drink or an email or something. Exactly.
We can't hear very well. Can you try again?
No,
we couldn't hear.
One day you manage to come to Barcelona because whatever reason, just contact us and we can organize a dinner or a lunch. Super fast, don't worry. We are super fast at organizing things. Like the remote that come up with the COVID, we get used to that.
Oh, you have a pet. Okay, no, I was actually thinking about coming probably for Cessa's dinner, like next week, just like one day or something. Yeah, like I can check the tickets, but I would love to because I didn't travel for almost a year, and I would love to actually. I'll check the tickets, okay?
Yes, of course.
Nice.
Qué genial. ¿Alguien ha dicho algo? ¿No?
Bueno, well,